What's going on, guys? It's Garrett Henderson, your electrician friend and mentor. Want to show you the new Fluke FEV150. This is the only device that you could actually test behind the scenes your EV charger output. Now, if you happen to scroll across my video and you had an EV charger installed, make sure that the installer had a device like this to test these critical functions. This is the only way you can do it. Let's get started. So, first thing I'm going to do, guys, is I'm going to turn on the unit. It's going to welcome me with the FEV150. Now we're going to go to the testing phase right now. So we're going to hit test. I'm going to hit select. I'm going to add a new project. And then I'm going to hit select. I'm going to add a station. And now it's going to ask me, is there two heads, two charging points? Because some chargers have two heads on them, right? With one power source. We have one. Our voltage is 240 volt. And our amperage is 32 amps. So we're going to keep all that the same, and we're going to hit save, and now we're going to begin the test. So we're going to select test, and now we're going to do a pre-test. So first thing we're going to do is plug in our charger. Now this guy is really pretending to be the car. This guy's going to be sending out signals and reading the results like your car would send out. Because the odds of an electrician causing a problem is only 1% of all fire department calls. Usually it's the control pilot signal that's failing. So let's get started. So here we go. We're going to do a pre-test. So I'm going to go down and I'm going to hit select. And it's going to ask me to put my finger. We're going to hit start. And it's going to ask me to put my finger here for a pre-test and then hit the test button. And it passed. So there's no obvious ground. If there was a miswire or a severe problem with line 1 being in contact with neutral and the breaker didn't trip, whatever the case, that's the pre-test. Okay, so now we're going to go back. We're going to do the next test, which is a visual test. So it's going to ask me, hey, is the cord look bad? Is the glass broken? Is there anything that I need to add here for my notes? Because again, this could all be saved, and this is a report you can give to your customer. So we're going to skip that because it's in my house and I know everything is good. Now we've passed the visual. Let's go to connection point 1 and let's start that individual test. Now the first thing is a GFCI test, which I'm going to do last because then I got to walk around and reset the GFCI. So that would be your first test. We're going to go on to the second test, nominal voltage. And that's how it's going to determine if we have the right voltage coming to the unit. If we look at it here, it's going through the test and it gave me these check marks. We're good. So now we're going to go back and stop. We're going to go back, and now we're going to go down to the next test, which is the control pilot test. This is the most important test other than the GFCI test. So we're going to select that and we're going to get started. It's going to ask us about CP state. It's going to ask us it's going to show us what the frequency is. It's going to show us what the pulse width modulation signal is. And that is looking fantastic. You can see it's at 1 kilohertz, 1.0150 kilohertz, which it should be. We've had a 53% duty cycle, pulse width module cycle. That's what it should be. And those signals right there is what causes the most fires. Okay, because when that signal gets crossed and the charger puts more current out to the car, that's when you have a fire. So the odds of an electrician doing it wrong is very slim. That's why you must get a permit. You must hire someone from the EVChargerFast.com network to make sure they have these records for you if you ever have a problem. Okay, so now we're going to go back. And now we're going to slide down to the next test. This is the proximity pilot test, also plug present test. Let's start that. Now in this test, it's looking for that this is plugged in properly. There's a voltage that communicates with that. Let's hit start. When this button here is pressed, and if you have a Tesla, it's a Bluetooth one. It's like a small little button you press here. Now it's going to ask me to not press the button. Don't press this button. I'm going to, okay, let's start. Now it's going to ask me in a minute to press the button. Okay, so it's going to say press and hold the button, which I will do. And I'm going to press this. And it's telling me don't let go, continuously hold it, which I'm doing, and it passed. So that's how the car knows and the charger knows that it's connected. Now, let's go on to the next test. We're passing all our tests so far. Error test, let's go into that. This takes a little bit more time, but let's go through it. So we're going to go right to the ground error test, and it's actually working right now. And it will give me, it's doing its test internally to see if there's any other ground issues. And once it's completed, it will give me a check mark or an error. It does take a little bit longer. Okay, it passed. This next one I know takes even longer. Let's skip that one. Let's go to the diode test. A diode is what is used to convert AC into DC. Let's start that one. And again, I know this passed already. I tried it, but I just didn't feel like you're going to sit and watch all these individual results. If you have, you have, but not detected on the CP. Check the Eevee SE. Okay, stop. So there's not a diode detected. Error D, I'm not sure what error D is. Let's go back. Let's go down. And that will conclude. And let's go back up to our GFCI test now, because now is where I'm going to have to go and go around. So I'm going to go back. It's going to ask me, do you want to do a quick trip? And I'm going to say yes. And I'm going to hit it. Not detected. That means that the breaker has tripped off. Let me go and reset it right now. Stand by. Okay, and it tripped my breaker off. You could see right here the breaker had tripped off. So now I'm going to reset that. Okay, so it shows that I got a confirmation that the GFCI did trip. And let's go back. And now we are pretty much completed. We didn't do the error test. Let's try that error test while we're here. And that way, Chris, you can hit pause. So we did the one. Let's do error test 1. So let's hit start. Chris, you can pause. Okay, that took about 30 seconds, I would say, that test. So we scrolled by that. Mains voltage not detected, okay, because it's going through its testing. Let's go back to diode. This one didn't work. Let's try it again. Not sure why this didn't work. I have to look into that, how this test operates. Pulse width modulator not detected on control pilot. Check the Eevee SE. Okay, I don't know why that would do that. Let's also go down to error D, and let's see that. Okay, pulse width modulator not detected. Okay, stop. We'll have to look in to see what that is, why that's giving me some sort of error there. I'll have to look at the instructions. Let's go back. And now we have pretty much completed every test. Now, the error test did not pass, but all the other items passed. So we've passed our pre-test, our visual inspection, our GFCI, our nominal voltage, our control pilot, our proximity pilot, and the error test did not pass. Let me do some more work on that. I'll get back to you. But guys, this is the device. This is a nice magnet right here that can be held to hold this thing up. I don't know if that's steel, which it is. So you could actually have a device, the device kind of hanging. Of course, that's not a good source, but that's a magnet. And again, this is the J1772. And Fluke, if you're watching, please send me the NACs so I can test the NACs. It's Garrett Henderson, EVChargerFast.com. Let's go take a look at this. In front of a dirty van because it's just too busy. So, when you want your EV charger installed properly, and you want some handsome guy like this at your house, you give EVChargerFast.com a call.